Here we go with Unit 5.02. We're going to continue to work on constructing recursive or explicit formulas for arithmetic and geometric sequences. So these are probably the two words that still are unclear, and that's what we're going to tackle today. So we've actually already seen an arithmetic sequence in what we did today. So let's go ahead and take a look at it. So write a recursive definition for the sequence shown in the table below. And then once you've done that, what I want you to do is I want you to draw a line vertically down your paper, and on the left side go ahead and show the work that you did to write it, and then on the right side we'll talk about it and you'll have your corrected work. Okay, so what we want to do here is look at the sequence and try and come up with the pattern that is happening to get me from term to term. So maybe I think about going from -2 to 4, and I could say, okay, well, I'm adding 6 here. Well, let's see if that keeps working. So I add 6 to 4, I would get, well, not -8. So adding 6 isn't going to work. So let's think of another way that could get from -2 to 4. Well, the only other way is to multiply -2 by -2. So the way to think about this, to go from here to here, is to multiply by -2. And so let's see if that continues to work. To go from 4 to -8, well, if I take 4 and multiply by -2, notice that 4 times -2 is also -8. And so this works perfectly fine. So to go from term 2 to term 3, I multiply by -2, from 3 to 4, and from 4 to 5, I just have to multiply the term before it by -2. So what I could do is I could say, let's define our sequence. So the initial term here, right, is the second term, right? So a sub 2 is equal to -2, and then the definition of my sequence is that the a sub nth term is going to be the a sub n minus 1th term, the term before it, times -2. Nothing too crazy, okay? What n values does this work for? Well, the only values we're given are from 2 onward. So we're going to say for n, this is for n, I'm sorry, I have to put it right down here. So for n greater than 2, right? Because we've defined 2 already, and so we're saying, hey, this will work for n greater than 2. And of course I could use regular function notation, so I could say f of 2 is equal to -2, and f of n is -2 times the previous term, which is f of n minus 1, right, the term previous. And this is for n greater than 2. Okay? Well, now let's think about how would we find the explicit definition here. So I'll go ahead and pause the video, and I encourage you to try it on your own. How would you find the explicit definition? So, all right. So thinking about the explicit definition, let's remember that our term is the n, our n value, the integer, and right, our value, well, that's the term value, or a sub n. So how will I figure out what the value of each term is if I only know the number of the term? Well, let's think about it. So if you were just to compute term 2, you would just want to have -2, right? Well, how would you go from term 2 to term 3? You would take that -2 and you'd multiply it by -2. So you'd multiply by 1 -2. All right, well now let's think about how would you get to the 4th term? Well, you could start with your initial term, you could multiply by -2 once, and then multiply by -2 again. So really, to get any number of term, I just have to count the number of -2's that I want to multiply by. For term 2, I want to multiply by no -2's, right? I just want to start off with -2, and I don't want to multiply it by any -2's. So I'm going to start with -2, and I'm going to multiply by a certain number of -2's. Well, I need to use the n, the term number, to tell me how many negative 2's I want. So if I have term 2, how many negative 2's do I need to multiply this by? 0 of them. All right, so it would be negative 2, and if n were 2, I want it to be 0. All right, well, if n were 3, to compute the third term, I want to take negative 2 and multiply it by 1 negative 2. So I need to somehow use the third term, the number 3, to end up figuring out that I need only 1 negative 2. All right, if I were on term 4, well, I need to multiply by 2 negative 2's. So hopefully you're seeing the pattern here. I take the term number, and I'm going to subtract 2 from it to figure out how many negative 2's I want to multiply by. N minus 2. Okay? And if you think about this, this works, right? Because when I have term 2, 2 minus 2 is 0. Negative 2 to the 0 is 1. So negative 2 times 1 is negative 2. If you plug in 3, you have 3 minus 2, which is 1. Negative 2 to the 1 is just negative 2. Negative 2 times negative 2 is 4. And it will continue to work, so on and so forth. All right, so if this was a little confusing, don't worry about it. This is an example of a geometric sequence. And so you can see that we're multiplying at each step by the same number, and as opposed to the previous examples where we were adding each step. So number 2 is optional for you to go ahead and try if you'd like, and we'll see it again soon. So don't worry if you're feeling confused and you want to just move on. Let's define the first type of sequence. It's called an arithmetic sequence. And what it is a sequence where the difference, which we'll use the variable d to represent, between each term is the same, right? So you might imagine, as an example, term 1 is 2, so we'll say this is a sub n, right? Term 1 is 2, the second term is 5, the third term is 8, the fourth term is 11, right? The difference between each term is 3. I'm adding 3 to get from each term to the next, right? And so here that difference is the value of d. Right? So for any arithmetic sequence, I can define it recursively, meaning I can say that a sub n, right? A sub n is equal to the term before it, a sub n minus 1 plus d. Okay? So, right, it makes sense. Any term, the nth term, I can find it by taking the term previous and adding that constant difference term. Okay? Now, how could I write this explicitly? So think about how you're moving from step to step. Each time, you're adding another 3. So you're starting with some initial value, right? This is why it's so important to define the initial value. And so let's define that initial value. This is an important piece of the definition. We'll say a sub 1 has to be equal to 2. And so then this definition works for any n greater than 1, right? Or starting with the second term. That's how we define it. So for n greater than 1, or we could say greater than or equal to 2. Okay, well now let's think about how we could write the explicit definition here. So a sub n is going to be equivalent to, and let's just think about how we can get to any term. So you are going to get to from term to term by adding 3 a certain number of times, right? To get to the third term, I'm going to need to add 3 once and then 3 twice. So if the first term I don't want to add 3 at all, and the second term I want to add 1 3, and the third term I want to add 2 3's, depending on the term, I want to add 1 less than the term number of 3's. So I will take the difference value, d, and I will add that many differences, n minus 1 differences, plus the initial value, or a sub 1. Right? And this works for any arithmetic sequence. Right? And this is, of course, for n greater than 0. This will work for any, right? If you think about it, if you plug in 1, a sub 1, well, this is going to go to 0 because 1 minus 1 is 0, and you'll be left with a sub 1, right? So in our example here, the way I would write that is I would say a sub n is equal to, the difference here is 3 times n minus 1 plus 2, right? And now you could compute any term just by plugging in the n value. Now we're looking at a geometric sequence. So a geometric sequence is, and this is just like the one we saw at the beginning of the lesson, is a sequence where each term after the first is found by multiplying the previous term by a fixed non-zero number called the common ratio. So let's take a look at an easy example here. Here's my term and then the value. Let's go 1, 2, 3. And let's say that the first term is 3, the next term is 6, and the next term is 12. Okay? Well, what am I doing here? To go from term 1 to term 2, I'm going to multiply by 2. To go from the second term to the third term, I'm going to multiply by 2. So what am I doing? Well, I'm taking the term before it and I'm multiplying it by 2. So for our recursive definition, okay, a sub n will be a sub n minus 1 times whatever the common ratio is, or r, times r. And of course, we'll have to define the first term, right? Because for my recursive definition, I can't use this to find the first term because it depends on the term before it. So here, a sub 1 must be defined, just like with the arithmetic sequence. And so then this will work for n greater than 1. All right, so now let's think about the explicit definition. And here we want to be able to say, okay, what is the nth term just in terms of n? Well, how does n help me figure out a specific term? If I'm looking here, the term number will tell me how many times I need to multiply by 2. So for example, to get to the third term, I'll have had to multiply by 2 twice. To get the second term, I'll have had to multiply my initial value by 2 once. For my initial value is 3, right? So how many times am I multiplying 3 by 2? 0 times. Right? So what I've got to think about is that I have my initial value, which is a sub 1, okay, whatever that is. So in our example, that's 3. And then the term is going to tell me how many times I'm going to multiply by my ratio, r. So notice that here, for the first term, we don't want to multiply by r at all. We just want to keep this first term. So we don't want this to be, 3 or 2 or whatever our r value is. We just want it to be 1. So we're going to raise it to the 0th power when n is 1, which will be n minus 1. That works. The thing about if n is 2, we want to multiply by 2 one time. Well, if you do 2 minus 1, you'll get 1, and that'll be 2 one time. So it'll be n minus 1 as the exponent. Okay? And so for our example here, a sub n will be our initial value, a sub 1 is 3, times 2 to the n minus 1. And I can try this out. So let's say a sub 3 is going to be 3 times 2. 3 minus 1 is 2. 2 times 2, 2 squared is 4. 3 times 4 is 12. And that's exactly what we get. Okay? If that was confusing, make sure you have a question ready to go. I'm going to put 2 more questions up for you to try. Make sure you comment and or answer someone's question, and I will see you guys tomorrow. So here are the next 2 questions for you to try. And one more.